Hi everyone, today we are going to use linear systems to help us solve mixture problems. Go ahead, grab a piece of paper and a pencil, and let's get started. Question number 1. A cleanser containing 20% ammonia is mixed with another cleanser containing 10% ammonia to dilute its strength. If 100 liters of this 17% mixture is obtained, how much of each cleanser was used? Okay, so I'm going to define my two variables. I'm going to let X represent the 20% ammonia, and I'm going to let Y represent the amount of the 10% ammonia. Okay, so next we're going to come up with our two equations. So the first equation is going to deal with the volume. So I don't know how much of each that I need, so I'm going to say X plus Y equals 100 is my first equation. My second equation has to do with all of the percentages. So 20% we're going to convert to a decimal. So we're going to write 0.2x, and we're going to do the same thing with the 10%. We're going to convert that to a decimal. So plus 0.10 or 0.1y is equal to, do you remember way back when you were probably in about grade 7 or 8, you talked about percent of a number? We did also review it in grade 9. So you'd have to take 100 of 70 or 17% of 100. So basically what we're going to do is we're going to take 100 multiplied by 0.17, and that's going to give us the answer on the other side of the equal sign over here. So 100 times 0.17. So we're going to have to go ahead and calculate that. Okay, so I'm going to have to use elimination to isolate either the X or the Y, and because it asks for how much of each cleanser, it doesn't matter which one we start with. I'm going to go ahead and multiply the first equation by 0.10. So I get 0.1x plus 0.1y equals 100 times 0.1 is 10. Next, I'm going to rewrite the other equation below. So 0.2x plus 0.1y equals, so 100 times 0.17 is 17. And we're going to go ahead and subtract those two equations to get rid of the y. So 0.1x take away 0.2x is negative 0.1x. The y's are gone. 10 take away 17 is negative 7. Dividing everything by negative 0.1. So x is equal to 70. So then we're going to substitute x is equal to 70 back into equation number 1. So instead of x, we're going to type in 70. 70 plus y equals 100. So y is equal to 100, take away 70, which is 30. And last but not least, we need a conclusion. So therefore 70 liters of the 20% ammonia is needed. And 30 liters of 10% ammonia is needed to make the mixture. Okay, so let's go ahead and take a look at the next example. Question number 2. A nut mixture contains 20% peanuts by mass and another that contains 40%. The two mixtures are combined to obtain 100 kilograms, which contain 36% of peanuts by mass. What quantities of each of the original mixtures were used? So we're going to go ahead and define our two variables. So I'm going to let X represent the amount of peanuts in the 20% mixture, And I'm going to let y represent the amount of peanuts in the 40% mixture. Okay, so again, we're going to come up with our two equations. So I don't know how many of each we need, so that will be my first equation. So it's just simply x plus y equals 100. The next equation is dealing with the percentages. So 0.2x plus 0.4y is equal to 100 times 0.36. We're going to go ahead and make that calculation. So 100 times 0.36 is 36. Okay, we're going to go ahead and isolate either of our variables. It doesn't matter which one we start with. I'm going to multiply the first equation by 0.2. So 0.2x plus 0.2y equals 20. And then I'm just going to rewrite the other one. So 0.2x plus 0.4y equals 36. And we're going to go ahead and subtract the two equations. So 0.2x take away 0.2x is 0. 0.2y take away 0.4y is negative 0.2y. And 20 take away 36 is negative 16. Dividing both sides by negative 0.2. So y is equal to 80. So I'm going to sub y equals 80 back into equation number 1. So x plus 80 equals 100. So x is equal to 100 minus 80. So x is equal to 20. Then we just need to make our conclusion. So therefore, we need 80 kilograms of the 20% peanut mixture and 20 kilograms of the 40% peanut mixture. Okay, let's go ahead and take a look at example number 3. All right, question number 3. How many kilograms of 30% salt solution by mass and 40% salt solution by mass should be mixed to form 200 kilograms of 37% salt solution by mass? Okay, so let X represent the 30% salt solution, and I'm going to let Y represent the amount of 40% salt solution. Okay, so our two equations. So equation number 1 is x plus y equals 200. The second equation is 0.3x plus 0.4y equals 200 times 0.37. Again, we're going to go ahead and make that calculation. And at the same time, we're going to multiply the first equation by 0.3. So 0.3x plus 0.3y equals 200 times 0.3 is 60. And 0.3x plus 0.4y equals 200 times 0.37 is 74. Go ahead and subtract the two equations. So 0.3 subtract 0.4 is negative 0.1y. 60 subtract 74 is negative 14. Divide both sides by negative 0.1. Divide both sides by negative 0.1. So y is equal to 140. Okay, next we're going to go ahead and solve for x. So I'm going to go ahead and we're going to sub y is equal to 140 back into equation number 1. So x plus 140 equals 200. So x is equal to 200 minus 140. So x is equal to 60. So therefore, we need 60 kilograms of 30% salt solution and 140 kilograms of the 40% salt solution to make the mixture. Okay, we have one more example for you to try. All right, question number 4. A lab technician wants to make 500 milliliters of 28% alcohol solution by mixing 40% alcohol solution and 20% alcohol solution. How many kilograms of each type should be used? Go ahead, define your two variables, set up your two equations, and eliminate. All right, you should get x is equal to 200 and y is equal to 300. Okay, that's it for today. Thank you very much for your attention. Bye-bye.